Hi, everybody. Welcome to episode 11. Amanda, we have a special series we're starting. Would you like to go ahead and introduce it?
Yeah, so episode 11 is the kickoff of a 4 or 5 part series. We'll see what we end up. We'll see where we end. We're unsure. Called Forensic Flaws When Science Challenges Customs. So we're going to kick off today in this episode laying the foundation. So we're going to have a conversation about the origins of forensic science, at least here in the United States, and sort of where it came from, so that we can get to where we are now so we can talk about some of the current issues that we're having. So, pop quiz. When was the first forensic lab started?
1906,
Ooh, close. 1910. Where?
New York City?
France. By whom?
No idea.
Edmund Locard. Come on.
Oh, really?
Yep.
Yeah,
So,
I should have got that one.
so Edmund Locard is considered the father of criminalistics, I think, is one of his official forensic science titles.
I,
And he came up with the idea that any contact leaves a trace. So when we think of like the exchange of materials, that's Edmund Locard. He was the one that sort of put that.
Locard principle. Any contact
Yep.
leaves a trace.
Any
Now, I
contact.
would just like to point out there was a guy who predated all this by 20 or 30 years by the name of Sherlock Holmes. And so I, the fictional detectives beat the real detectives, right?
They did. Yeah. Yeah, they did. So the first forensic crime lab in the United States was in Los Angeles, of all places, in 1923. New York didn't get one until the 1930s, I think, and J. Edgar Hoover didn't open the FBI forensic lab until 1932. So when we think of forensic science in the United States, it's a fairly new territory if we think of labs not being developed until the early 1900s.
Didn't forensic toxicology, though, start in New York City? Am I getting those things confused?
No, are you talking about the arsenic case
Mm-hmm.
where he was able to demonstrate in court in front of everyone the on the stomach contents? Yes, I think that was earlier 1900s. I'm trying to think. I can't even remember now. I can't even remember the
I
chemist.
thought it was in the 20s.
Yeah, probably late teens, early 20s. Um, Now, to kick us off, when when you think, okay, let's start here. When you think of forensics, when you hear the term forensic science, if you can think back to when you first heard that term, what comes to mind?
Fingerprints.
Oh, that's good. What else?
Uh,
Like, what is it? What did you have a working definition of forensic science the first time?
no, I didn't, Amanda.
So for me, for my generation, I feel like when we hear the term forensic science, we think of CSI.
Yeah, I'm sure that's right.
That show is so prevalent. Even though I didn't necessarily watch a whole bunch of it. It was such a cultural juggernaut that I think when I hear the term forensic science, I still think of CSI, even though I work in forensic science, which is a
Yeah,
little bit lame. But um, the working definition, and we may have we talked about the working definition of forensic science already in
I
one of
don't
our
think so.
previous. So forensic science broadly is just anytime we're using science in law, right? So anytime we're bringing it in, so it has an incredibly broad effect. I mean, you can really coin most anytime you're using science in the court of law as forensic science, technically. But again, when most people think of it, we're thinking of like crime
Criminal,
investigation.
ju- the
Yep,
criminal justice system.
yep, and the criminal justice system. And the I would argue that one of the main issues that we fight even now, or that we're fighting against even now, is because of where forensic science labs started.
I agree with that they came out of police departments and they were not directed by scientists.
Right. So, and if you had, I don't have a number for this. I'm just genuinely asking. If you had to guess, what would you say proportionally the number of crime labs that are still housed within police departments? I would say like probably 80%, over 80%.
That's what I was going to guess, 80 or 90%.
Yeah, that's what I would say. So even with a lot of the issues and concerns, because there are concerns, I mean, police officers have a very distinct job and their background is usually not in science. Plus, you also have the, would you say it was an ethical question of having police officers responsible for the evidence that may or may not take away somebody's liberty?
Yeah, there's a decided imbalance in this, and even if there's not overt bias, there's certainly the potential for unintentional bias in this, and we see it.
Yeah.
Particularly when you look at the resources that are available to the prosecution versus resources available to the defense.
Right. Oh, that's an excellent segue into talking about the second major issue. So I would say the first major issue or first major flaw in forensic science, so foundationally, is that they started in and are still mostly currently housed in law enforcement agencies. The second major flaw, I think we could argue, is that our adversarial justice system makes it very difficult to discuss the nuances of science, right? You have the one side against the other, and one side, as you mentioned, has more money.
Oh yeah, absolutely. And if you consider that that adversarial system, the way it's set up, it's not necessarily directed to find the truth. It's directed to make arguments to support one side's or the other's version of events. There's nobody whose job it is to say, no, this is what the truth is. Absolutely. That, I think the supposition is that's what the prosecution's supposed to do. But as you and I both know, we've seen examples where that's not the case.
I think from an expert witness standpoint, which is really where I think forensic science comes into play, right? You have people commenting on what certain evidence means in an expert capability. There is no, and I use this, so I remember you saying this in one of my, I think it was when I was getting my master's degree, talking about there's no checks or balances in forensic science currently. So like if you're a doctor and you kill a patient, there's an investigation. If you're an engineer and a bridge collapses, there's an investigation. If you are a forensic scientist and you testify, regardless of what side, and you testify and your expertness takes away somebody's freedom and or potentially life, and you were wrong, nothing happens.
Yeah, that's exactly right.
Right. So when we think about it in terms of that, and then we look at that adversarial system and who is responsible for determining whether someone is an expert witness or whether evidence should even be admissible, we are dependent on judges.
And judges are incompetent in the area of science. And I mean that quite literally. They are not competent to judge science. They're not trained in science. They're not scientists. They're legal experts.
Right. And in the United States, for those of you who didn't know, the judges are the ones who determine whether an expert can be considered an expert and testify. And they are also the gatekeeper of what evidence is admissible or not. And so most judges, I don't want to be overgeneral, but I would argue that because they do not have a strong background in science, most judges err on the side of letting most things in.
Yeah, to
Has
the
that been your
detriment, which is why
experience?
you have people like psychics being admitted into court when there's zero, none, nil, zip, nada scientific evidence to suggest that you can psychically determine a murderer or anything else.
Well, there's plenty of documentaries out there that would try to disagree with you, but we'll let that one slide.
None of them scientifically valid.
It's true. Okay, so we have where forensic science labs are housed. We have our adversarial system. Is there a third? Is there a third pedestal leg that we're going to stand on here for our forensic flaws?
Yeah, I think the biggest, and this next one is the biggest one. It's and it's in our tagline. It's that so many techniques are built upon custom or history and not built upon scientific proof, and yet they're presented as if they were science.
So you mentioned fingerprints. That's a really great one because fingerprints is probably the oldest form of forensic science that has been used in the United States as far as identification of people. You could maybe argue that it's the oldest form of identification, individual identification.
Pretty
Like in
close.
the history, I think they were using, I know was it China? They were using like fingerprints on the bottom of ceramic vessels or clay vessels to
Yeah, I bet
identify.
I hadn't thought of that, Amanda, but I bet you're right.
So if we talk about fingerprints, when I teach forensic science to my students, I talk about the three sort of main branches of forensic science. We have pattern evidence, which are things like fingerprints and tool marks and ballistics. We have biology, which is sort of where we're housed, DNA being the gold standard of that. So DNA, other fluids, pathology, entomology, anthropology. And then we have trace evidence. So things like hair and fibers. I know. Soil and pollen. So
yeah, there's foreshadowing for future episodes. Trace evidence.
Trace evidence. Pattern evidence also includes things like, did I say bloodstain pattern analysis? Bloodstains are in pattern evidence. So let's start with fingerprints. Just very briefly.
So the big example is the false identification of a Spanish bomber, of a bomber in the Spanish train bombing. And was that 2008?
Yeah, I think so. Yep, 2008.
And there was a man in Seattle, Washington, had not been out of the country, but was definitively identified by his fingerprint by the FBI, was it not?
Yep, I think also a hint of where we may go in the future. We're going to mention the FBI a couple of times,
and it may not be in a good light. What are the chances of that?
Oh, J. Edgar Hoover, that guy.
You know, stand on your record, and the record is not that good. And this is not one of the agency's brightest hours when they arrest and prepared to extradite a guy who I think it was pretty demonstrable he'd never been out of the country, for heaven's sakes.
Yeah, let alone to Spain. And I think was there 6 fingerprint analysts that analyzed those fingerprints and all said that it was that person?
Yeah.
Yeah, I think it was. And then
need we give the punchline? It absolutely was not that person. This person had absolutely nothing to do with it. And it called into question what it means to make a fingerprint identification.
Yes. And I think we'll get into fingerprints in a later episode talking about fingerprints specifically and like what the current requirements are for making identifications.
Which there was no standard. And is there even a standard now?
No, it's determined by district. I mean,
Yeah, I mean, there's no national standard for how many points of identification equal,
a match.
which isn't it? Well, we'll talk about it more, but
Yeah.
on the just on the surface, saying that it seems absurd.
Yes, I agree. It does. Okay. Before we go too far down this rabbit hole, because I want to devote an entire episode to
Okay,
pattern
I can back off.
I would like you to take us down the path of how evidence moves into a court of law, because I don't think that that's something that a lot of people are familiar with when we talk about like Fry standards or Dauber, like what is required for something to be considered evidence in general, but forensic evidence specifically.
Well, I think this is something that TV kind of gets right, unlike a lot of things. The physical, all this physical evidence is recorded with a case number and bagged and placed in a log, and then every single person who has contact with that has to sign off on the log. And at no point can you have a situation where anybody looks at this physical evidence and it's not recorded. And so, and then that carries through all the way to court when the prosecution or defense will ask to have it admitted, and they'll have the assignment number. And the only time I think that we see questions about this, if there's questions about what's called the chain of evidence, whether at some point it wasn't kept in custody. So from that standpoint, it's not unlike what you see on TV.
Mm-hmm.
One thing I will say that I see they get wrong all the time is, and I also will use this. You've probably heard me say this in lectures to students, that you can use this as a sign when a police department is in over its head, and that is putting bags on hands. That dead bodies, you always bag the hands and the feet, but definitely the hands, so that you can look for trace evidence that at autopsy. And if the hands aren't bagged, it's an indication that this is a jurisdiction that doesn't deal with homicides very often and doesn't really understand what the requirements are to properly process a scene. And I will make one exception. If you have advanced decomposition or bone, someplace where things are completely gone, yeah, at that point it doesn't make any sense to bag the hands. But prior to that, I mean, that's just standard operating procedure. And yet, I will see footage of bodies being moved without the hands being bagged. I've seen that, and I know it exists. So it's not. I guess the point I'm trying to make is, even though these rules of evidence exist, they are not universally applied the way they should be. And this is also why discovering some piece of evidence long after the fact, where there's no chain of custody, that's not going to fly in most jurisdictions. I mean, you can't suddenly come up with something out of the blue. Oh, I was at the crime scene and I found this thing there and I'm going to bring it in. No, the real world doesn't work that way.
I would argue that you would think that that's true, but as we know, even here in Nebraska, it's not always necessarily.
No, I know it isn't. I don't want this to come off as a police bashing episode.
It's absolutely not. They have an incredibly important job. I think the argument is that there is no single standard practiced nationwide consistently, right?
Absolutely right.
So it makes it very difficult, I think, for officers who are in that position, because this is not what it's like elsewhere. So if we look at England, for example, their crime scene techs are civilians outside of the police force, and their whole job and training is to go in and collect evidence. Like
Yeah, and
that's what they
there's a
do.
level of independence there, and
Yeah,
one would hope that you would have a level of professionalism, because in fairness to police, you often have people working scenes who
yeah,
are relatively untrained to work those scenes.
right. So I would argue, if anything, we are overworking our police officers by asking them to do too much and asking them to do things that they may or may not have training for.
Yeah,
Um,
I agree with that. And I think it has to do with the broader issue that this series is about, which is that our court system hasn't really moved with the times and hasn't accommodated um, uh, what the requirements are when you're using science to try to solve problems. And so there's sort of a baling wire and duct tape sort of approach to these things that too often fails.
Even if we look at it from an admissibility standpoint, I mean, what we still are all states Daubert now? I think they might be. So when we talk about evidence admissibility, there for a long time was not. I think you could just like bring in whatever you wanted, right? It was hey, I'm going to show the court this whether it's directly related to this case or
Yeah,
not.
absurd.
And then in the early 1920s, Fry I think was in 23 maybe.
Maybe you should explain what we're referring to when we say fry.
So Fry was a court case, correct?
Yes,
1923 court case. I don't actually remember the case, so this is
it was versus a tire company, wasn't it? Fry versus something or other tire.
Kumho Tire, or was that later?
No, that's that. I think that's it.
Kumho Tire. And during that trial, the court realized that there needed to be some requirements on what could be considered evidence and what not. And so what they determined in 1923 was that if you are going to bring evidence into the court of law and it had a scientific basis, it had to be generally accepted by the scientific community, right? So, but there was no specificity. That was literally what it was. It could be allowed if it was generally accepted by the scientific community. What's a scientific community? What does accepted mean? Was there a percentage there? None of that was given. It again was a general rule for judges to follow when determining if evidence could be accepted into a court of law. But then we could ask the question, well, who is the judge asking if it's generally accepted by the scientific community? If you're asking someone who's going to testify on it, well, of course they're going to say that it's generally accepted. So a little later, 1993, I think, Daubert versus
Dow.
Dow. Okay. Daubert versus Dow. They decided to take Fry and make it a little more specific. So they had 5 standards. Error rate.
I have them right here. It's
is there a known error rate? I know that's one.
the theory can be tested and assessed for reliability. That this theory or technique that's being used has been subject to peer review and publication. Mm-hmm. As Amanda said, there's a known or potential error rate. There are standards and controls used, And then finally, the last one, that it's generally accepted by the scientific community, whatever that means.
Right. So again, there was no definitions given for what those means, but it does give a few more measurable steps for a judge to look at to see if something is considered scientifically sound. But again, like, what, from a testifying point of view, like, I've never been challenged on
No,
those. And maybe it's because we're at a point now where entomology is accepted enough. But I mean, how often is it, even with these asking those 5 questions, how often is a judge gonna be like, oh, I don't know, is this?
well, to give you a good example of this, Amanda, I'm working on I'm revising a paper on how big a difference adjusting temperatures makes at crime scenes, how big a difference it makes in estimates. And so I'm using your data, or our data, I guess I should say, Rowan Higley.
That's
I'm
right.
using our data to recalculate some times of death. And in the Hagen case, I get a time, if I use the raw numbers, I get a time of death while the victim was still alive. Not a surprise, because I hadn't accounted for maggot mass temperature and some other factors. But my point in bringing it up is, in terms of things I absolutely know the stage of the insects we collected. I have an excellent idea of their development time, but I still have approximately a day that I have to interpret and say, well, this went faster, slower, and here are the reasons, and this is why this estimate is a good one. And I need to articulate those things. So is that part of the error rate? Is that part of, or is there no error rate? Is that part of my scientific judgment? And I'm not called out on that stuff in court.
Yeah.
And that it surprises me that, and error rates have been a big point of concern, and lots of people will talk about error rates, but the problem tends to be that, how do you estimate that? What's the error rate on fingerprints? People would have said there's a 0 error rate, which we know is not true, but because nobody actually did a series of studies looking at this, and I, correct me if I'm wrong, I'm still not sure that they've been done.
I think they've been attempted, but not much has come of them.
I'm doing I'm doing some two-fisted drinking here. I got water here and I've got coffee. So
I just this morning I have Tetley's, which is
a switch.
Yeah, I did switch. That's the nice round tea bags that fit nicely in my cup.
Oh, very
good. The only
good.
downside is that they don't have a string, so you have to like fish them out with a spoon. But it's good tea, so I'm willing to do that. I'm willing to make that sacrifice.
So, those standards present a problem for us, and the adversarial system, in what we would like to say is science. There's one set of facts that we should be able to agree on, and when I would argue, if we don't agree, we should be able to highlight in great specifics where it is we don't agree. But we should never be in the situation of having one doctor argue this way and another doctor argue the opposite way, because both can't be true.
Right.
As I don't know if that we've mentioned in here, but Amanda and I are co-authors on the draft of a paper just asked to do this simple thing, just require written reports, which isn't, I mean, it seems like that's the simplest thing you could ask, is to require a written report so you could have it available for review. But even that is not a requirement right now for scientific testimony, which I don't know, strikes me as I can't say in a scientific journal batshit crazy, but that's what I want to say, because it makes no sense.
That's what the podcast is for, though, right?
I guess so, if I'm allowed to use that language. But yeah, the idea that you're testifying about something scientifically, but you don't have to have that written down with your logic,
or any data,
or show any data delineated.
Yeah, agreed.
Mind-boggling.
bananas. Would you agree that part of this issue, so we've laid a lot of blame on adversarial system not letting scientists determine what science is moving into a courtroom. But I feel that we could also say that there's this weird idea perpetuated culturally, I feel like, to some extent, that scientists have to always have an answer. That saying I don't know to a question is a negative thing, or like it's perceived as something negative. And so especially when you get up in front of a judge and a jury and they're asking you, so for you and I, we can say, yes, this is the age of the maggot to some degree of specificity. Yes, we know that at this temperature for this species, this is a typical growth rate. And when you're up there, because we've mentioned already on here, like how exhausting and sort of scary testifying is and can be, when you're up there, and I think research has been done showing that even if you are not telling the truth, if you state it confidently enough, the jury believes you. And so I think we've partly backed ourselves into this corner a little bit by expert witnesses going up there and testifying with confidence about something that they may or may not be comfortable with, but saying it confidently means that it's accepted as factual and the jury trusts them, and then it turns out that it's not.
Yeah. Well,
because instead of saying I don't know, we don't have the research to support that. No one has looked into that. It's safer in that instance to lie or to overinflate what you think you know, or maybe some of them do feel that that they were 100% right and there was no way that they could make a mistake. But so that's just arrogance, I guess, at that point. But it's sort of the idea that it's safer to confidently overstate than to say I don't know.
Oh, very definitely. If you say I don't know enough, you won't be used as an expert witness, given the nature of the system. And I think, to my mind, part of the problem is I think that the notion of expert opinion is confused. It doesn't mean opinion in the lay way. It doesn't mean what you think. It should mean what your expertise tells you, not a belief that you may hold for whatever various reasons you may hold it. But I've seen experts testify as if it is their opinion in the broad sense that they're allowed to testify. And I think to me, that's a really big problem in the system. In terms of assigning blame, I'm willing to assign blame, and it's not on the court system, it's on Congress, because there've been repeated calls from professional panels for reform on this issue, and they fail to act. And Congress will call for the National Academy or somebody to do they'll get to do an investigation, they'll get the report, and that's what's happened with the last report. Congress has failed to act on a single item that was in the last survey on forensic science, and there were some damning points there. I'll link that report actually here with this podcast if people want to have a look.
Are you talking about the 2009 report?
Yeah, I mean, you don't have to read the whole report. You could just look at the summary at the end to see, well, these seem reasonable things that could be done, and yet Congress has done nothing.
Yeah, so that was done by the National Academy of Sciences, and I think it would behoove us actually to dedicate one podcast episode to that report.
That's a good idea. We could do it as part of this series, in fact.
Yeah.
Well,
because I think it is important, particularly since it is now 2023. That report came out in 2009, and I actually remember when that report came out. The American Academy of Forensic Sciences meeting that year was lit, as the young kids say. It was, I mean, that was a fire of a meeting because you
I
had
didn't
this
like what was
massive
said.
you had this massive report come out that basically sent everyone except DNA into the fiery flames of damnation. It was like nobody can confidently say that what they are doing is based in any sort of data driven
Rock
research.
solid foundational science.
Right. And except for DNA. And I will come to that in this series. It might be a 5-episode. It might be a 5-episode series. But I think it's important. I think it's important considering it was 2009. It's now 2020.
Yeah, I think that's a good idea. Well, it sounds like we're getting close. I've got a thing to before we finish. Have you seen this book?
No, but it looks beautiful.
Well, it is beautiful, and I can recommend it not just to so it's The Lives of Beetles, A Natural History of Coleoptera. Sorry.
There we go. Okay. Yep. Ooh, dung beetle.
So
yeah, beautiful pictures.
The photographs are superb. There's pictures of a lot of interesting species. Those beaver parasite beetles that you hear about but have never seen. There's pictures of those in here. But you should get a copy, man. And actually, if you have any interest in beetles at all, this would be a great book to get because it has a very readable text. I'm about halfway through right now, and I'm loving it.
I am currently working on finishing up a beetle tattoo on my body, so I feel like that justifies me purchasing that book.
That was so sad. That was so sad. Okay.
Sad?
I don't think I can go on after that. So
oh jeez. We've talked about identification of people by tattoos and shark attacks, and you can't handle a beetle tattoo?
Yeah. It's funny. We were in the car asking what tattoo everybody would get. Do you know what if I was to get a tattoo, you know what it would be?
I'm gonna go off the wall and say something like Cthulhu.
It's not even an image. I would like to have here on my wrist tattooed the ideal gas law, because every time I have to teach it, I can't remember which parameter is which.
Oh, if we're going in that direction, then citric acid cycle for me, man.
You're gonna need a lot of room for that.
I've learned, and when I was in college, it was the Krebs cycle, so it's even changed names since then. But I've learned that stupid cycle, I don't know, over a dozen times probably. I mean, I've had to individually memorize it over a dozen times, and I'm like, yeah, there's ATP that comes out at the end and glucose goes in at the beginning. So the citric acid cycle, just for those of you who also don't remember it along with me, is taking sugar and converting it into cellular energy in the form of ATP. So I don't know, there's some NADPH in there, I think. And
that's exactly right. It's kind of important.
Water, I don't know. Doesn't matter.
All right. So I guess well, my cups are empty. So I know we have to be near the end.
Yeah. Your dual cups? Both of your cups are empty?
Both of my cups are empty. So
okay.
All right. Well, we'll see you again next time.
Sounds great. Bye.
Bye.